Oil spills. They happen frequently. They can be devastating both to the economy and to the environment. In the past, cleanup of oil spills in open water, such as lakes and oceans, have been done by use of skimmers and chemical dispersants. Dispersants present environmental concerns. Skimming is an old, inefficient technology. Now there is a new, green, totally environmentally safe method of oil slick removal. It's called the gravity drain. Imagine being in a shower or a bathtub. The water is on top of the base of the shower or tub. When the plug is pulled, the water passes down the drain, through the floor, to the sewer system. The water is gone. Gravity has done the work. Now imagine if oil slicks on the ocean could be removed the same way. Down a drain. Pull a plug and away goes the oil. It can be done. The glass of water and oil represents an ideal oil slick. The oil floats on top of the water. This is because oil weighs less than water. Now imagine that the water is the floor of your shower and has a drain in it. You pull the plug and the oil flows down the drain through the water, leaving the water surface clean. Well, it can be done. It's called the gravity drain, and it's an entirely new concept in oil spill cleanup. Let's go back to the model we saw at the beginning. This device represents a proof of concept tabletop demonstration of the gravity drain. Of course, this model does not represent the entire operating device in the ocean, so let me describe the difference. The actual real-world device is a barge that can operate in open water such as a lake, bay, or ocean. The barge is either pulled or pushed through the oil slick. The barge has three basic elements: a funnel or collection apparatus, a gravity drain, and an oil collector. The funnel is in the front of the device. It is not represented here, but its function will be simulated. The funnel is a large, bottomless, V-shaped device, which, by being moved through the oil slick, increases the thickness of the oil on the surface of the water. That is, the oil layer gets thicker. The funnel is not absolutely necessary, but it will increase the efficiency of the gravity drain and be attached to it. The funnel would go on the right side, where indicated. The second element is the gravity drain itself. One possible configuration of the gravity drain is represented here. This is not an optimal configuration, but for the purpose of this model and demonstration, it will suffice. The bottom of the gravity drain would be open to the ocean water. Also, the right-hand side of the gravity drain would be open to the funnel in order to admit the water and oil that it has collected. As you can see, the actual drain proceeds down and to the left into the oil collector, the third element of the barge. In operation, oil will flow down this drain and across to the oil collector. Again, in a real-world device, the collected oil would be pumped out of the oil collector to a larger vessel for consolidation and transport. Now we will do a tabletop demonstration of the gravity drain using this model. First, we will add salt water representing the ocean flowing from the funnel. The water is tinted blue for filming purposes. During this phase, you saw that the intake on the gravity drain rises with the water, so that the seawater does not flow out of the drain. As you can see, no water has flowed through the drain and into the collecting tank. In a real-world device, some water would flow through, and it would be removed by being pumped from the bottom of the collector. Now we will add a layer of oil to simulate what would be delivered to the gravity drain by the missing funnel. The oil is being added slowly to simulate the layer of oil on top of the water as it would be received from the missing funnel. You can see the oil flowing through the drain and into the oil collector. This oil separation is accomplished by the force of gravity alone. You'll notice that there is almost no oil relative to what was decanted remaining on the seawater. You have now seen something that is completely new, a revolution in oil spill cleanup. I hope this demonstration has shown you something new and exciting, a way to preserve and protect our water resources. Thank you.